Okay, number 9. You have to know that this is an accumulation of area starting at -3. So if I start collecting area right here, okay, right here, and I go across, we're talking about the area forming. But all of this area so far is negative. So that is a negative number, more negative, more negative, more negative, more negative, more negative, more negative, more negative. Once you pass that 0, now you start adding area. So it's at about here where you'd have a total answer of maybe 0, where the red and the blue cancel each other out. Okay? So they want to know, where is this total amount of area going to be as small as possible? Well, that would be when it's most negative. And that's at where the red region stopped. So it'd be at 0. Okay? The other way to do that, that's how I do it just with common sense. The answer is at 0. The other way to do it is to use the definition of a minimum. Okay? Here's my option 2. Minimum would be when the derivative is 0. Well, the derivative of this, if we call this f of x, then its derivative is the fundamental theorem part 2, where you just undo the derivative and replace the t with an a. Okay, I wrote mix instead of minimum. Okay, so now a minimum would be when the derivative is 0 and changes from negative to positive. Well, this is f. So when does this equal 0? Right there, and it changes from negative to positive. So there's 2 ways of doing that. Okay, that was number 9. I mostly think it's easier to understand it by visualizing accumulations of area.